So we're here at the example table, and in this video we're going to find the difference quotient of the function 1 over x plus 2. So just to remember what the difference quotient is, let's draw a little sketch. Let's say this is a function f, not going to be the same function as the one we've got there. Let's draw a line through this. Difference quotient is basically the slope of this line. So if we call the x-coordinate of this point x, and the x-coordinate of this point x plus h. Between these two things now we have a distance of h. If we trace each point over to the y-axis, here we get f of x, and here we get f of x plus h. What's the difference quotient? It's just the slope of this line. So the slope of the line, remember, it's rise over run. Change in y, this is change in y, over change in x. Change in y is just the distance between these two things, so it's f of x plus h minus f of x all over h. So I keep emphasizing this. It's a formula you need to know, but it's much easier to remember if you know where it comes from. So remember this reasoning, but also remember the formula. So let's apply it to this particular function on a clean sheet of paper. So f of x plus h here is going to be 1 over x plus h plus 2. Then we're going to subtract f of x, so 1 over x plus 2. And now we have this whole thing over h. And we want to simplify, right? We just found the difference quotient, so in some sense we're done answering the question, but what we really want to do is simplify. So we should always think of these questions as saying find and simplify the difference quotient. We just found it, now let's simplify. The first step here is to find a common denominator for these two expressions in the numerator. And the common denominator in this case is just going to be the product of the two denominators. So the first term we need to multiply by x plus 2 over x plus 2. So we get 1 over the quantity x plus h plus 2 times x plus 2 over x plus 2. I guess we don't really need the parentheses, but sometimes in these cases where we have a lot going on, it helps to clarify things. Now the second term, we want to multiply by the other denominator. So we get 1 over x plus 2 times x plus h plus 2 over itself. So times x plus h plus 2 over x plus h plus 2. And once again, it's this whole thing over h. Let's note now that dividing by h is the same as multiplying by 1 over h. We're going to use that in the next step to make it a little bit clearer. So what does this thing equal? Well, here we now have everything over a common denominator, and that common denominator is x plus h plus 2 times x plus 2. Right? Remember, it's just the product of the original two denominators. What about what's going on the top? 1 times x plus 2 gives us x plus 2. And then minus 1 times this thing. So minus, and we have to remember to put this in parentheses, x plus h plus 2. And I said, dividing by h is the same as multiplying by 1 over h. It's going to be a little bit easier to write. So let's just say this. So times 1 over h. But what happens in the numerator here? We have an x minus x. We have a 2 minus 2. So the only thing that we're left with is this h, and it's going to be minus h. So this is minus h all over x plus h plus 2 times x plus 2 times 1 over h. But now we have an h in the numerator, we have an h in the denominator, so they cancel. Now, remember this negative, right? A negative h over h doesn't cancel the negative. So this simplifies to negative 1 over x plus h plus 2 times x plus 2. And in a case like this, unless you're told otherwise, there's no reason to expand the denominator. So here's our answer.